Let's start with a question. What is the average value of a function? We should start by specifying a domain, so let's think about what the average value is on the interval from A to B. This could be the average temperature at a particular location during a particular interval of time, or the average distance from the Earth to the Sun, or lots of other things. Let's look first at the simplest type of function, a constant, say 3. Here there's only one candidate for the average, namely 3. What about the line y equals x on the interval from -1 to 1? Since there are symmetric parts above and below the x-axis, the average value should be 0. What about this function on the interval from 1 to 3? If we shift our first graph to this one, the average should shift along with it, so the average here is 2. But what about something that's not linear? Let's look at sine of x on the interval from 0 to 2 pi. This is again symmetric with respect to the x-axis, in the sense that there are equal parts above and below the x-axis. So the average should be 0. But what about sine of x squared on the interval from 0 to the square root of 2 pi? Now the part below the x-axis is smaller than the part above, so the average should be positive. It's also reasonable that if the function were changed so the negative part got farther from the x-axis, then the average could be made 0 again. It becomes 0 exactly when the areas above and below the x-axis cancel each other. So we use area to define the average value. The average value A of f of x on the interval from A to B is the height of a rectangle whose base is the interval from A to B and whose area is the area between f and the x-axis on the interval from A to B. In other words, capital A times b minus a equals the integral from a to b of f of x dx. So the average capital A is 1 over b minus a, 1 over the length of the interval, times the integral from a to b f of x dx. For example, suppose that the temperature in degrees at a particular location is given by the function f of t equals 60 minus 15 times cosine of pi t over 12. T is measured in hours after 5 a.m. What's the average temperature between 9 a.m. and noon? We need to figure out 1/3 times the integral from 4 to 7 of 60 minus 15 cosine of pi t over 12 dt. We take an antiderivative, evaluate it between 4 and 7, and we can simplify to get the answer of approximately 58.1 degrees as the average. Now we can talk about the mean value theorem for integrals. If f of x is continuous on the interval from a to b, then the average value of f is actually achieved at some point c in the interval from a to b. In other words, there is a c in ab such that f of c equals 1 over b minus a times the integral from a to b of f of x dx.